Hello everybody, back at the Duce robot, and I've kind of been wrestling around here. I don't have any of this stuff going today. This is a video that I wanted to make because I wanted to talk about the rotary encoders. Yes, probably not a very exciting thing to hear about, but rotary encoders are important in a real robot design because they give you odometry. They let you know how far you move forward or backward, things like that. I won't need speed control because the robot moves at a set speed and it doesn't need to slow down or speed up because it's just perfectly set to where it's not jerky and it runs right. But you do need to know where you're going. But I had a problem, and that's the whole reason for this, is I did not have motors that came with rotary encoders on them. They didn't make them in this size with rotary encoders in the motor itself. They did make it with a unit that hooked up to it that gave you the rotary encoder. But it was more of an industrial application. It wasn't microcontrollers. You probably would have had to go through a lot to tie it into the system, and it wasn't designed, didn't work like these do. Because these have to tie into that, and then they have to tie into that, and tie into that, and tie into that computer. And there's going to be a lot of things that are tied together in here. And then this has to tie into everything. That's the motor controllers down there. There's a lot. But here's the encoders. They're not finished yet. They're just kind of tacked there with one screw piece. And if they look a little wonky, that's because they are. They're just there basically where they're going to go, but they're not permanently fastened yet because I have other things to do. There's a lot of stuff that has to be done with those yet. The wiring, they're all installed, and I had to make my rotary encoders. I couldn't buy fancy ones. I had to make custom ones. So there's a rotary encoder to a wheel. Gives you forward, it gives you backwards. It gives you your odometry. That means it's going to give you the rotations of your motor, how many pulses of a rotary encoder go when the wheel goes one full rotation. And a rotary encoder is a lot like the volume on your stereo, how you feel it bumps around as you go, and you can kind of set it very precisely. That's what rotary encoders are. So there's a lot of computing and stuff, and there's a lot of code that has to go, and the code is already in these. Provided by the DroneBot Workshop. Bill there. Thanks, man. What a sketch. I mean, I'm glad that it didn't seem that important to me at first, Bill, but now that I get further into the project and I see what you're doing, I realize that it is. So I did do the sketch where it gives you forward, it gives you backward, it gives you the values. And what it does is when you're moving backwards, that LED goes red, and then when it goes forward, it goes green. So I have those. So those are the taillights, or at least one of the taillights, because I have a really cool taillight that it doesn't have the lens on it yet, but it's right there in that box right there. It'll get a lens on it. That's a really cool RGB sketch that's in there. But also, in the wheels themselves, there's going to be there's taillights in there. They're in there. So that will light up red and green when it goes forward and backwards. Same thing for that one. So you're going to have your 4 tail lights there. 1, 2, and then the 2 in the wheels. And then from there, I'll have to try to tie into the nano, which is the brains of the operation here. There's going to be a couple of them, though. I'm not quite sure how all this stuff goes together because I'm still learning. So that's basically the whole lowdown on the rotary encoders. We're right here in the middle of putting everything in still. It's a pretty good size project just to get those in. I mean, I had to make that rig right there to be able to get a rotary encoder of some kind on the robot, because without it, you're going to have a tough time putting some of the systems in because they rely on it. They need to, even though it has distance sensors on it, and it's going to have the sweep LiDAR and everything, it still needs these so that it can position itself accurately. So it can go through the pulses that are in the rotary encoder and know how far it went. or get a rough idea of it. So that works along with the arm. So imagine the arm going to pick something up, and it has to move in the direction of the item and the object that it's picking up. So it has to be able to know how far it's moving, what direction it's moving in, and all that, so that you can operate the arm so that that can get programmed in, which all goes into a it's an application called Move It that goes into the ROS robot operating system, and that helps you put the nodes and everything together, and the algorithms to make the robot intelligent. So it can make the robot not only move, but make it have a little bit of an intelligence capability to it, aside from the AI and the algorithms you're going to try to put in through its neural networks and all that. Yeah, before you see me writing those kind of sketches, it's going to be a little while yet, because that's hard stuff to do. I mean, I really give those guys their merit that can do that, because that's what it's all about. You know, the system, there's no size limit in robots. So if you look at this system that I'm putting in here, and then you can say, oh, well, it could do all these things and it does all that. Well, you can take the same system and put it into the tiniest robot, and it's the same thing. It's all about the system. Or you can take that same system, like what I'm speaking of, and take it and put it into a gigantic robot and change little parts of the code, and it's the same thing. So there's really no size limit. It's all about the systems. I mean, obviously you have to know how to build, but once you get the programming and everything down, you can program a lot of different types of robots. So it's an experience. It's a learning experience. Very fun. I mean, I wish I would have gotten into it 20 years ago. I mean, I'd be doing these videos from the dock of my mansion. So, but is what it is. So enjoy, everybody, and then next time I get back here, I'm going to have a video up of this moving, putting out all of its readings, and you know, the taillights and everything will be working, the odometers will, or the rotary encoders will be working, and just starting to get another system in place to get all of these working, and then get them all tied in. It's not just, oh, put it together and plug it in, and you know, everything has to prove that it's going to work first, and then it can be put to the system and try to make what's called a node out of it. So each thing gets its own little compartment. Each little part of the robot gets its own little compartment, you know, in the programming, like the base, the arm, you know, all the voice, all those things, and they all get put together in a system where the robot can access it itself. So it has a lot of capabilities. It can learn a little bit. Has like AI. It really isn't. AI is artificial intelligence because it isn't real. It's, you have to program it. So it's really what they really call it now is machine learning. So hopefully it'll be able to do some of that. Hopefully we can get it up and going within the next few months. You can see how hard this is. It's not just slap a little toy together and it starts running. Don't go like that. So, till the next video, which isn't going to be that far away, because I'm right in the midst of getting these rotary encoders hooked up now. Everybody have a good week, and try to stay safe and not get sick, and hopefully we all get back on track here pretty soon. We can get this economy up and rolling again. So, everybody have a good week. Over and out.